Hello students, welcome back to our classes. So just a quick review what we have learned in our previous lecture before we can start the new things. So the first one is a review, then we will talk about the vector graphics, and then we also have the scalable vector graphics, what are the basic shapes and how we can build those scalable vector graphics that are more what you can say that scalable based on different screen sizes, based on different sizes of the images and so on. So we will talk about that one. Before we start, I hope that everyone is okay and everyone is in best of his health and spirit after this lockdown, all these like living in a limited space and so on. So have you all of you cope up with that particular specific difficult times very well. So let's start. So what are the learning outcomes of this course? This lecture is describe the differences between the raster and the bitmap images and the vector graphics. So after the end of this lecture, we will be able to understand what is the difference between the raster images, which are the bitmap images that we have studied earlier, and the vector graphics. Define, and we can also be able to define and give examples of the basic shapes available in the scalable vector graphics and create the basic scalable vector graphic images, how we can create it, how we can develop it, how we can make those images for our purposes. So first thing is that if you remember correctly, I mean it's a long time now, it's a more than 4 weeks that we are out of touch. So posterization or bending can occur in the images when the bit depth of an image is reduced, and you know that what is a bit depth. Bit depth mean that that particular image is actually what you can say that it's a 24-bit raster image, or it is a 16-bit raster image, or it is an 8-bit raster image, bit different levels. So I mean, how much bits we are using to encode the information of each pixel, so that is the bit depth of an image. So if we are trying to reduce the bit depth of image from 24 to 8-bit, so we had 24 1/3, so then there is a possibility that these kind of effects, which are the posterization effects, can occur. And the reason is that we are trying to minimize the information which are available in the 24-bit, and when we convert it to the 8-bit, so the informations are lost, and due to that particular specific loss, these posterization issue can occur. The visual impact of the posterization can be reduced through different techniques. One is a dithering. Dithering can create an illusion of increased color depth. Okay, it is an illusion. Again, it is not the actual. We have only 8 bits instead of the 24 bits, or 16 bits instead of 8 bits information. So instead of 24 bits of information, so it is not going to increase any information in it, but it will try to create a delusion because our eyes have limited capacity of the vision. So accordingly, we are trying to deceive our eyes that we are looking at a high quality picture. Image with the reduce of the dithering can create the illusion of increasing the color depth in the images with a reduced palette. We are trying to reduce the palette, the information that are color informations which are present over there. So if we look at that, this is an optimized palette, and then on the other side, if we look at that, the palette is more like we also have a green color here, and then if we look at that, these small dots of the green colors are visible here. But if we just try to optimize that particular specific color palette, we can get rid of that particular specific green dots which are appearing on the forehead of that cat. So for a distance, the patterns are not visible and improve the perceived quality. For a distance mean that if you're looking very closely, you are magnifying that image, then of course you will be able to see those details, and you will see that there is a problem with the image. But if you are looking from a distance, it means that you are not from some distance, that maybe 2 meter or 3 meters, so you can say that yeah, the image's quality is not that bad. The this Okay, so we can try to optimize the palette. So standard palettes will have an even spread of colors. The standard palettes normal, which is a higher, I mean, if we talk about the 24 bits, we have a 16 million colors. So 16 million colors mean that that particular palette will be a lot of colors and their shades which are included in that particular specific palette. But on the other hand, the palette optimization replaces the standard color palette with those which are most used in the particular image. So instead of using the standard RGB palette, which has 256 colors across all RGB values, instead of using the standard palette when we are doing the palette optimization, if you look at here, we are having a fewer information or fewer uh, colors has been used. So why we need to provide all the colors which are available in the standard palette? So we are trying to reduce that standard palette with the colors which are only used in that particular specific image. So in this way we can optimize, and once we did the optimization, for example, we have converted that 24-bit raster image into an 8-bit image, so we also have that polarization issues. And then if we just only optimize the palette, we can increase the quality or the visual quality of that particular specific image. So similarly, if you look at the ocean picture, then most of the colors which are there, they are blue, so we can optimize the palette accordingly. Then we have the aliasing. Aliasing can result from the poor image sampling, and you know that what does the sampling mean, that in one particular specific area, you can say that in terms of the image, that how many samples, how many information we are capturing about that particular specific scene or the image. So upsampling occurs when an image resolution is increased. I mean, we are trying to take more samples. The image resolution has been increased, the number of pixels has been increased, so we have more samples of that particular specific image, we have more information about that image. So that is upsampling. The image editing software has to create new pixels based on the existing pixels. And if we have already have a picture and then you say that no, I want to increase its resolution, then of course we need to create those new pixels which are additional. Okay, so we have different algorithms that can help us to build those new pixels. And similarly, when we talk about a downsampling, it means we are trying to reduce the resolution, and when we are reducing this resolution, it means we need to, what you can say, that pixel based on the old pixel, maybe 2 or 3 pixels combined together in one pixel. So we are trying to find out a way, an optimized way to make this new pixels from the already existing 3 pixels. So we are not like saying that we are deleting these out of 3, we are only deleting 2 of them, but we are combining those information together in one pixel of information. So the creation of the new pixel is called interpolation. So when a sample of or reconstructed image differs from the original, an alias exists. An alias, you can see that hence this term is aliasing, because alias is seen. Aliasing can result in the jagging or the moire patterns emerging in the resulted image. So we have discussed in more detail last time. Anti-aliasing mean that we, as a process to smooth out the jagged edges, these jagged edges, which are now, this is the original one. So here, if you look at that, these are the jagged edges. So we are trying to smooth it out so that it look more better quality of the image. So this is a process which help us to reduce the effect of the aliasing in our images with the reduced quality or reduced resolution. Then we also have different type of the compressions. Remember the bitmap images, the BMP images, they are uncompressed. They have all the information about each and every pixels, whether it is an 8-bit depth information or the 16-bit depth information or the 24-bit depth information. And similarly, we also have a lossless compression. So lossless compression in the GIF and the PNG, it means that they are trying to compress the information which are present about each and every pixel, but they are trying to reduce the size of the file image file. And they will also try to preserve all the information which are present in the BMP or uncompressed file. So they will try to preserve, they will not lose any single bit of information, but they try to reduce applying some specific compression algorithms to reduce the size of the image. On the other hand, if we talk about the JPEG, JPEG is lossy compression. It reduce the size of the compression, but during that particular specific compression algorithm, during that compression process, it also loses some information about the original image. So that's why it is a lossy compression. So we have seen the we have seen some comparison last time that even the lossy compression will give you a very good quality of the pictures, yet it give you a very small size of the file that is more suitable for the internet movement or transfer over the internet or transferring between the over the network to share those images and the files. So now we talk about the vector graphics. A raster or the bitmap graphics store images information in the pixel array. It's an array of the information. For example, if we have a 40 by 60 mean 40 rows and 60 columns, or so we have total, like we can say that we have total 2400 pixels, and for each and every pixel we are recording the information about its RGB values, or one way or the other we are recording each and every information about all 2400 pixels. So they are not scalable. I mean, they are 2400 pixels, they are 2400 pixels. And as you know that if we have the high resolution screens, then that pixel will become smaller. And if we have the small resolution images screens, then this same image, the same information, the same file will be bigger on that. We have already discussed that. So they are not scalable. They are as it is. We have all the information about all the pixels which are present in the information. So that is our raster image or the bitmap images. That is the same where you can say that even we talk about the lossy compression or the lossless compression, that is PNG and the GIF, or the JPEG, which is lossy compression. They also try to provide you the same raster image but in a compressed form. But that is the array of the pixels that we have. On the other hand, the vector graphics store image information in form of a structured equations. Like we can say that if we say that x square plus y square is equal to r square, that is this equation of circle. So if we know the position of x and y, and we know the what you can say that the radius, that is r, so x square plus y square is equal to r square. That is give me the information about that particular specific, what you can say that circle. And similarly, if we look at the equation of line, y is equal to ax plus b, where a is the slope, b is the y-intercept. Okay, so we are trying to save the information about our image in form of the equations, the standard what you can say that the basic shapes: line, rectangle, circle, ellipse, polygons, polylines, paths, and texts. So in this way, this scalable vector graphic SVG store the information in form of the mathematical equations, and that make it more scalable. We can increase the size of those images, we can decrease the size of those images, we can adopt it to different resolutions of the screens without any issue, and more or less they will give you the high quality images on different resolutions or on different sizes. So instructions, so vector graphics is contains the instructions to draw a square. For example, go to a position. So when we want to draw a square, so what is the algorithm that we can use to do that? So go to a specific pixel location and face north, face south, face east, face west, and then pen down, repeat 4 times, move 10 times, and so on. So we are drawing that particular specific just like with our pens. Okay, so we can see those instructions are scalable, whether we, I mean, they can become more independent of the resolution or the size of that particular specific rectangle. They can be, because they are more scalable as compared to the raster images where we have exact information of exact number of pixels. So scalable vector graphics file format is a W3 standard. W3C is a World Wide Web, www. That's what W3, and it is a community which is making all maintaining all those standards, HTML5, JavaScripts, and so it is a standard for from that particular specific organization. So SVG is a set of instructions that browsers, our browsers like Firefox or the Safari or the Chrome or the Internet Explorer. Now we also have the Edge on the Microsoft. So follow the order to draw a specific shape. SVG files can be created using a basic text editor. I mean, we can simply open that particular specific file in our what you can say that notepad, and in that notepad we can save that particular specific file in the form of with the extension .svg. Okay, svg is an instructions are written in the XML form, just like an HTML, you can say that more or less. So svgs are replaced the has replaced Adobe Flash, which is the older one. It has been replaced by the svg. So there are three ways to instruct the browser. I mean, we can tell the browser in three different ways to draw a specific image for us. One is as an image. So we can have that particular specific file name that we have saved in the form of an SVG, and then we can tell that you go to that particular file, read it, and draw it as an image for us. As an object, we can embed that particular specific. Again, we are saying that we have iframe or embed source. So again, we have that particular specific image file, that svg file, which is exist on our file system, and we are embedding that particular file as an object in our HTML or in our to tell how the browser can draw, or as an inline instructions, or we can write whatever the code that we are writing in the svg file, we can write directly inside our HTML file, and it can actually draw those images. So these are the three different ways, whether we are printing that, we are displaying that image as an image or as an object, or it is a part of the HTML code itself. So these are the three different ways that how we can instruct the browser to draw that SVG. This is a simple example here. So what we are saying that in the beginning, we are telling that it is an SVG, it is a tag, starting tag or ending tag, just like HTML's starting body and ending body, or the HTML's tag and the starting and ending tags. So we are telling that it is an XML namespace. The second number is XML and namespace. So, and then we are telling that from where that namespace exists, which is coming from the internet, and what is the width of that particular specific image, what is the height of that particular specific image, and then we are telling about that we are going to draw a circle. In this circle, we are giving three different informations, or actually four information. The first information is CX. CX means that what will be the X position of the center. We have, if we talk about a center is a point, so we need X and Y coordinates. So we are giving the X and Y coordinate of the center, what will be the radius of that particular specific circle, and then we are saying that we are going to fill that particular color. The color that is going to be filled within that circle is yellow. What will be the stroke width? Stroke is the line. What will be the width of that particular line? And the stroke is equal to green. It means that we are saying that that particular line will be green. So we are, if we try to copy paste these information into a notepad and save that information, save that file as a .svg, and then we can show that particular specific circle like this. Okay, so simple. Now we are not telling that how many pixels are there, what are the informations about the pixels, what is their colors information, and so on. No, we are just saying that we are going to draw at the pixel information, or at the point 50-50, we are going to draw our circle of the radius 4. So whether it is a high resolution or the low resolution, we can just simply increase that particular R value. The size of the circle will go up and down. So it's simple, straightforward mathematical notation that we are using to represent that circle. So image mode is the least flexible. Image mode is the least flexible. It offers no way to control the drawing by users interactions or the JavaScript, for example. And the image, if we are, as you see that we have three different way. We can have the inline mode, we have the object, or we can show that particular image as an image. So image mode is more like it's kind of a fixed information. It will just read one time and it will display that as an image. And the users cannot interact with, although there are maybe we will see in the later that we will have multiple objects in that particular SVG, but we cannot interact with them. So the object mode allows the JavaScript interactions. The object mode, it is an object. So all the objects which are we have drawn a circle, then we have a rectangle, then we have a line, then we have ellipse. So we can interact with those. Inline mode is the most flexible one, because now we can give them the names. Like we have a circle that we can allow a specific name to that particular specific circle. We have a line, we can give a specific name to that particular line, and then we can individually access those elements inside our JavaScript. And then maybe we want to do some animation with those objects inside our SVG, we can do that, no problem at all. So the least flexibility is in terms of the image. When we are displaying the SVG as an image, we also have allow the JavaScript interaction with the object. We can move that object as a whole. And if we talk about the inline mode, when we are giving that particular specific SVG code inside our HTML file, then we have more flexibility. We can, even within that particular specific image, we have different objects, we can interact with them, and we can try to do some animations using the JavaScript libraries nowadays. For example, here we say that we have an object. So when we say an object, so we have given that data is coming from that particular specific SVG file, type is an SVG, and then we can interact, we can give a specific name to that image, and then we can interact with it. Similarly, when we're trying to embed as an object, allow for the raster image fallback. So when we say that we have an object and inside we have the your fallback.jpg, so we can change those informations. We can interact with that particular specific object, and then when we are putting that particular specific object as a inline code, we have say HTML body, and then inside the body we are putting that particular specific circle. So now we can directly access this particular specific circles, and we can animate, we can change the colors, we can change the line color, we can change the width of the color, we can change its position X and Y. So we can do a lot of things with that when it is inline. So now we talk about the basic shapes which are available inside our scalable vector graphics. So scalable vector graphics has these basic shapes. One has a rectangle, the other one is circle, ellipse, line, polyline, polygon, and the path. Rectangle is very simple. We know that it's with a specific height and width with the right angle between its sides. So this is a rectangle, so we can just simply create that particular rectangle using the width and height. What will be the style of that particular specific fill? What color we are going to fill, what is the width of the line, what is the color of that particular specific line. We can give all those information as a properties in the rect element, and it will create a rectangle for us. The style attributes is used to define the CSS property. The CSS file fill property defines the fill color of the rectangle. Stroke width represented, width of that particular line, and the color stroke itself representing the color of that particular line. We can all elements has a number of other CSS styles. What are those? For example, we can say that the X position and Y position where it will be drawn. I think black line not part of the image, only introduce show x and y. So we can say that 50 and 20. So you can see that it is at 50 and 20. So top left corner is represented by this particular specific point, from where that we will start drawing that particular specific rectangle, and what will be the width and what will be the height. So when the height and width are same, it means that we are drawing a square, and then we are giving the fill information, and then we also have a stroke opacity. Stroke opacity mean that we are trying to tell that there is some, what you can say, that transparency, you know, just like color. So we can change that particular specific, and we can see the objects behind that or not. So opacity of the information, so if it is 1, it means that it is fully opaque, and if it is 0, it means that it is not opaque at all. So we need to see all those. We can play with that particular specific and see that what exactly those meanings are. Similarly, we have circle. So we need to provide the center, where will be the center of that circle, what will be the radius, what is the stroke, what is the width of the stroke, and what is the fill information about that. So these are, in this way we can have a circle, and the element is CIRCL circle. For the rectangle, it is RECT rect. And then we also have ellipse. Again, first information, first to CX and CY, these are the center, somewhere here, the center, the point, the coordinates of the center, CX and CY, and what will be the X radius. If you look at that, the radius along the horizontal, along the x-axis, or along the horizontal direction, what will be the radius of that particular ellipse, and then the RY is the vertical radius. So we can give those information. If these Rx and the Ry are having the same value, that will become a circle. And then again we are giving the style information, what will be the fill, what will be the stroke, and what will be the stroke width. Similarly, we can draw a line. Again, the element which is a line. So again we are providing two different points. The first point representing the x and y coordinates of the starting point, and second x2 and y2, they are representing the coordinate of the second point, and we will draw a line between these 2 points, a straight line. Again, we are giving the RGB color, the RGB stroke. We don't have the fill information because it's a line, it is not a closed image. Similarly, we have a polygon. Polygon is used to create a graphic that contains at least 3 sides, at least 3 sides. Of course, with 2 sides we cannot create a polygon, so we have at least 3 sides, 3, 4, 5, 6, 7. I mean, it's totally up to you what you want to play with that. So what is the polygon points? So we have polygon, and then we are giving the points as a string. The first 2 values, 210, they are representing the point 1, the coordinate x and y coordinates of the point 1, the x and y coordinate of point 2, which are 250 and 190, and then 160. And if you look at that, there is a comma between that, so 200 comma 10 space, so that is representing the first point, so x and y values. And the second, again after space, we are giving 250 point comma 190. It means that we are saying that this is the second point, this is the third point. Similarly, we can add more points, and actually it will increase the number of sides. So what is happening here, it is between 210 and 250 and 90, draw a one line, then it draw a line between 250 and 190, 250, 190 and 160, 210, second line, and then from the last point it again draw a line to the first point. So that becomes 3 different sides, and it is a closed image. Okay, so kind of here we can say that it's a triangle, 3 sides. If we try to increase another point here after this 160 comma 210, then it will become a 4-sided polygon. Okay, so again we are giving the fill information, or the stroke information, and the stroke width information. These are the style of that particular specific image, or the object, you can say that. Then we also have the polygon. Polygon mean that it's a shape that is not closed one. If we look at that, the polygon, what we are trying to do, from the first point we draw a line to the second point, From the second point, we draw the third line to the third point, and then from the third, which is the last point, we are drawing a line between the third and the first point and making that particular specific image closed one. On the other hand, the polyline is, you can draw multiple lines, but they are not going to become a closed image. So what's happening here? So we are giving again the points. Polyline is the element, and we are giving the points in the form of an what you can say that in the form of string. The first point is 2020, and the second point is 40, 24, 25. So what happening? So it is draw a line from the point 2020 to the point 40, 25, and then it draw a line between 40, 25 and 60, 40. So this part here. Okay, so maybe I can show you the laser pointer. Yeah, so you can see that particular part. This is the part which is showing up as the second line between 40, 25 and 60, 40. And similarly, from this line is actually between 60, 40 and 80, 120. And similarly, the next line is between the 80, 120 and 120 by 140, and then 200 by 80. So we are trying to draw all those lines between all respective images, respective points. So this is what you can say that the polyline, the difference between the polygon and the polyline. Okay, so you can, polygon is a closed image, polyline is just an open image, but we are drawing the images. We are not drawing a line between the last point and the first point. Okay, so that is the difference between the polygon and polylines. Then we have the path. Path is more like we are giving some instructions. Movement element is used to define a path, and follow the commands are available for the path data. For example, we have different set of instructions that we can give. Move to mean we are asking that go to that particular specific point. Line to, we are trying to draw a line between to a specific point. Horizontal line, vertical line, curve to, smooth curve, quadratic Bézier curve, or we can have a smooth quadratic Bézier curve too. And then we have all these different type of instructions, and then we can tell that what we can do. The above commands can also be expressed with lowercase letters. Instead of the capital letter, we can also have the lowercase letters. The capital letters means absolute positioning, and the lowercase letter means the relative positioning. Relative positioning means it's become more scalable, and if you want to make it an absolute position, then it means that you want to use the capital ones. So this is the difference between, you can make it fixed or you can make it the scalable. So what is happening here? We are saying that we are say M and then say 150, 0. Okay, so it means that we are say that go to that specific point, move. Now if you look at that, we have move to. So we are saying that go to 150, 0. Then we want to draw a line L, line 2. So it means that we come to that specific point which is 150, 0, and then we are drawing a line 75, 200, 75, 200. Okay, 150, from 150 we go back to the 75 on the x directions, and then on the y directions we are moving to the 200. And then from again we are drawing a line. Now our, what you can say, our position, our focus is from this point come to here, and then from this particular point we have drawn a line. We are drawing another line. We are drawing another line from 225 and 200. So 225 and 200. So we are trying to draw those lines. And then we have Z. And what does Z mean? Z mean it is a closed path. So what will happen? What happen mean that we move at a specific point, or this, again depending on what is the what canvas of our image. So we have moved at some point, we draw a line, we draw another line, and then we are saying Z. When you say Z, it is a closed path, it's a closed image. It means that we are saying that we want to close it. From where we started, we are going to draw a line automatically. From the last point, we are going to draw a line to the first line. From the point 225 to 200, we are drawing a line between 150 and 0. So 150 and 0, okay. And then we have 75 and 200, and then we have again the x remain the same, 200 and 225 or whatever. I mean, we need to figure out that where that particular specific lines are going, but this is how we can do that. So we are saying that go to the point this 150, 0, draw a line between the 150, 0 and the 75, 200, and then again draw a line, because now we are at the 75, 200. Draw a line between this point and this point, that is 225 and 200, and then at the end we are saying that this is a closed image, it is a closed path. It means that we are going to draw the line from the last point to the first point and make it a closed path. So that is the one example of the path. We also have the Bézier curves are used to model the smooth curves that can be scaled indefinitely. And the Bézier curves have two endpoints and one or two control points. What does that mean? I will show you when the examples come. Then two or more control points, two endpoints. So we want to draw between 2 points, a curve between 2 points, and then we also have the two control points. So the Bézier curve with one control point is called a quadratic Bézier, and the Bézier curve with the 2 points is called a cubic curve. So if we have only one control point, it means it's a quadratic curve. If it is we have two base control points, then it will become a cubic curve. So this is the quadratic curve. Quadratic curve means we have 2 points between which we want to draw a curve, A and C, and we also have a control point which is controlling the curve, controlling this particular specific curve. How this curve, if that point is near, so that point curve will be a little bit smaller as compared to more depth. So start and end point, and B is the control point. Here we are going to, so we have a path, so we are saying that we have D, these are the informations about those. So we are moved to the point of 100 and 350, 100 and 350, that is the point A. It is, we are telling Q. If we go back to our line, so we say that it's a quadratic Bézier curve, quadratic Bézier curve. So first of all, we are telling that we are going to move to that particular specific point. Then we are saying that it's a quadratic Bézier curve. 150 minus 300, so 150 minus 300 and 300 and 0. Okay, so 150, 300 is the point C, and the 300, 0 is 300 and 0 is the end point of B. It means that it is the control point which is controlling the depth of that particular specific curve. Okay, so we have endpoints A and B, control point and then endpoint B. Okay, I think that we need to see that what's happening over here. So but in any case, so we have one control point, and then we have a lowercase q points are relative to the start point M, relative to the start point of M. Okay, so we are not making it fixed, we are making it because it's a small case. So relative to the starting point of the M, we are accordingly, we are what you can say that we are making the things together. So starting from 100 and 350, so when we say 100 and 350, so now this will become the origin, this becomes the 0, 0 point, relative coordinates, this becomes the 0, 0 images, 0, 0 point, the origin. So now we have, this is the y-axis, this is the z-axis. So here we are saying that the 150 and minus 300, so 150 and minus 300. Okay, so that is what you get, minus 300. We are going to the negative side, because in the images on the screen. When we are going down, it is increasing the y value. When going up, we are decreasing the y value. And now the origin is here 0 0, so that's why this is minus 150. So this second value after q, this point 150 minus 300 is actually representing the b, and the 300 is representing the point c. So that should be c, not b. So again, if you look at that, they are at the same level. So the value of the y is 0, but the value of the x is increasing on the right side and decreasing on the left side. So it is 300 on the right. So it's a 300. So now we understand what do you mean by the relative lowercase q points are relative to the starting point m. Starting point. So when we say small q, it means that this point from where we are right now, that becomes the 0 0 image, and or the origin of our coordinate plane or Cartesian plane, and then all the points are based on that particular specific relative to that particular specific new origin. Okay, normally on our screens, our 0 0 point is actually top left corner of the screen, but when we are trying to use the small or the lowercase letter of the these paths behaviors, then actually the m, the first point where we are right now, that becomes the origin 0 0, and the all the other points will be relative to that. Similarly, we also have a text. I mean, we can display the text on our scalable vector graphics. We have text. We are providing where you want to draw that text, or the place that particular specific text, x and y position, the point where you want to place that one, what will be the fill information, and then at the end we can give the information actually itself, what will be the text itself. So we have a text, we have provide the position, what will be the fill style, and we give the text, and then it closing that particular specific slash text element, and it will display the text on that particular specific SVG file or SVG image. So this is more complex one. If we look at that, we are starting that particular specific SVG tag, then we have a rectangle tag which is drawing that particular specific rectangle, then we have ellipse tag which is drawing this particular specific ellipse, then we have a line which is drawing that red line, then we have a polygon which is drawing that particular specific green polygon. If we look at it, we have 4 sides, 1 2 3 and 4 sides. So we have 4 sides, and we can see 4 points here, 1 point, second point, third point, and the fourth point. And because it is a polygon, it will draw close that from the last point to the first point. Again, we have a path is yeah, it's a Q, it's a quadratic Bézier curve, quadratic Bézier curve we have draw, and then at the end we draw some specific text. We are giving the position of that particular text, where we want to place it. We are also telling that we want to transform, we want to rotate it at some angle, and awesome picture. So this is the picture, and all these elements, rectangle, line, curve, polygon, ellipse, text, we can interact with them because they are the independent objects inside that particular specific scalable vector graphics. We can also use the Illustrator, Adobe Illustrator, to build the SVG. Okay, we can also have another what you can say that Inkscape. That is also another software which is freely available. Adobe Illustrator is available through our what you can say that through our UCOL account. We can get it. I'm not sure that about students that you can also get that particular specific Adobe products free of cost or not, but this particular specific Inkscape is also a free of cost, so it's free or available free of on online open source software. You can download and you can build those beautiful scale vector graphic images. So I think that is the end of our lecture today. So thank you, and see you all soon.